So, hello everyone. Now, today we are going to talk about the chapter 14, the selected problem from the chapter 14 of the AoPS Volume 1. It's about the geometry of the angle chasing. So, let's start with the first select problem is 236. So, we have an isosceles triangle is ABC, where AC is equal to AB. We are going to look into how we can parameterize on the geometry. Okay, so then we have the other one is the BD is perpendicular to that, and also the BD is equal to the BC as well. Okay, so now we can parameterize. We know this one equals, so we have two isosceles triangles, and we know A is 57 degrees, right? So now we can know this angle, right? So we want to ask what is D, right? So we have many, we have isosceles triangle, and we have the right triangles, okay? So now we can see if this is the 57 degrees, this one will be the 33 degrees, and this one, because of the AC equals to BC, right? So you can see this is also 57 degrees, right? So 57 minus this is 24 degrees, right? So you can see on the other isosceles triangle, okay, that's this one. That's the BCD, right? So BCD is an isosceles triangle. This side equal this side. You know the vertex angle. You want to solve the x. So x is equal to 90 minus half of the vertex angle is 90 minus 12. So it is 8 and 7. Yeah. So when you do angle chasing, okay, I mean, be calm down and be patient. Don't be feel very, I mean, very just kind of scared. You can chasing every angle and to see what the angle you know and to get what you don't know. Okay, you need to see all the isosceles triangles, right triangles, yeah, or equilateral triangles. Yeah. So next one. So question number 240. Okay, so in the figure we have the triangle is the, we have a circle. Yeah, we have the excuse me, we have the triangle RTS and the triangle UTV. We have outside point of the T, right? We have this point of U, S, V, R. Okay, we have the RTS and we have the UTV. Okay, so these two triangles are congruent. Okay, if you know they are congruent, right, then this is the 42 degrees. R is 36 degrees. What is the RQV? Okay, so if you know, we want to know the RQV, right? There are two things you need to know, okay? The first is if I have the A, B, C, D, E, okay? If I have the A, B, C, D, E, I have two secants, right? So I connect, I have two chords is B, D, and C, D, and the extension meet at A. So if I want to know this theta, right? So you can see theta is equal to theta is the exterior angle. Okay, theta is the exterior angle of the triangle of this triangle. Okay, theta is the exterior angle of the EOB. Okay, so it's equal to the alpha plus the beta, right? So theta is equal to alpha plus the beta, right? So you can see alpha is half of the arc ED, and the beta is the half of the arc BC. Okay, so you can see the angle theta is equal to half of this arc. The angle theta is spanned by this arc and this arc, right? This is also the theta. So you can see it's half of this arc plus half of this arc. And the other important result is the angle gamma here. Okay, so the angle gamma, right, we can see the angle gamma is equal to, if we see this is the beta, right? So this is the alpha as well, right? Because the ED span this angle, span angle EBD, and span angle ECD on the same circle. So this is also the alpha. This is the 2 alpha, right? So the gamma is the exterior angle. So angle beta is the exterior angle of the triangle ECA, right? So the beta minus the alpha, right? So the beta is the angle beta is half of the BC. The angle alpha is half of the ED. Half of the BC minus ED. Okay, so you can see the theta is half of the BC plus the ED, and the gamma is half of the BC minus the ED. Okay, so we need to use this important result. Okay, so now let's see. So we know it's this is 36 degrees. So we know this arc is 72, right? We are going to solve the RQB, right? So this angle, right? So the angle of this, let's see, this is the alpha. So the angle alpha is equal to half of arc RU plus half of the arc VS. Okay, so we know of the RUVS already, right? Half of the arc VS is already 72 degrees. Okay, now the next, we think we want to solve the half of the arc RU, right? Okay, so solving this arc, we are going to use the congruent. It's mentioned the RTS, congruent UVT, right? So we know this angle is 36, right? And we also know this chord is equal to this chord. If the 2 chord is equal, that means this arc is equal to this arc. Okay, so let's see, this arc is M, and this arc is also the M, right? Okay, now, and we also know this is the 42 degrees, right? Now we can see the 42 degrees is equal to the half of the arc RU minus half of the arc VS, right? So it's equal to half of, so we can get it is the 84 is equal plus the arc of the VS is equal to the arc of the RU. So we can see the arc of the RU is equal to 84 plus the VS is 72. So this is the 156 degrees. Okay, so the RU is 156. Now we can solve the alpha, right? It's half of the 156 plus the 72 is equal to the 36 plus the 78. Then this one is 4 is 114. Okay, so it's 104 degrees. Move on to solve question number 241. In question number 241, we have the ACD is a triangle, and we have the BD is a right angle, and the CE is the angle bisector. And we have know the angle A is 50, the CFD is 110, the CE bisector, and the DB is the altitude to the AC. That find the angle CDF. Okay, so we know that's parameterize this angle is alpha and alpha. So we have a 90-degree triangle of the ABD. So this one is 40 degrees. Then what we know is this angle is 90 minus alpha. So we have the 90 minus alpha equals to 180 minus 110 is 70. So we solve the alpha equals to 20, right? Once we solve the alpha, we can solve this angle, right? So this angle is the right triangle BDC. So this angle is 90 minus 2 alpha. So now we know the angle CDF is equal to 90 minus the 2 times alpha is equal to the 50 degrees. Okay, so the angle tracing, you need to parameterize and construct the equations. So triangle ABC is an isosceles triangle with a base of AC. Triangle ABC with the base of AC and B. So the point P and Q are respectively on the CB. The point P and Q respectively on the CB and AB, such that AC equals AP, P, and AP equals PQ, Q. And it also equals QB, so we have this one, this one, this one, this one. So we want to find B. Let's see, B is X. So this is the X. This is the exterior angle of the QBP. So this is 2X. Then this is the 2X. Right? So this angle is parameterized, right? You see the power of parameterized, okay? 4X, right? So this angle is equal to this angle is equal to 180 minus this 180 minus the 180 minus 4x plus x, right? So this angle is 3x. So this angle is 3x. Okay, but remember, and the ABC is an isosceles triangle, right? So 3x equal to 90 minus the half of the vertex angle. So now we see the 2 of the 7, right? X is equal to 90. Now we can solve the x is 180 over 7 degrees. Next problem 243. Okay, so we have a circle with the center of the O. We have a circle with the center O, and AD is the diameter. AOD is the diameter, and the chord B and the AB and the ABC is a chord. ABC is a chord. Then BO is equals to 5. BO equals to 5. Then A ABO. So CD, this arc is 60, right? So we know this angle is 30. Then the ABO is also 60, right? Okay, so you know arc CD is 60. The inscribed angle of the DAC is 30 degrees, and this one is 60, so you know this is 90 degrees. So if this is 90 degrees, right? Okay, so now we want to find the of the BC, right? So if we, because it's the diameter, if we connected the CD, we know here is the 90 degrees, right? So now we kind of constructed, we know this is the 5, so we can, this is 30, 60, 90, right? So we know this is the 5 root 3, and we know this part is 10. So now because AO is the radius, right? So it's a 5 root 3. So based on the similar triangle, that the triangle of the ABO will be similar to the triangle of the ADC, right? So now you can know we want to know the AC, right? We want to know the AC. So AC over AD is hypotenuse, right? Is equal to the AO over the AB is hypotenuse, right? So the AC over AD is 10 root 3 is equal to the AO is 5 root 3 over AB. AB is 10, right? So then we have the AC is equal to 15. If AC is equal to 15, then BC is AC minus AB is equal to 5. Okay, now let's do the problem 247. Okay, so the triangle PAB is formed by the PR and the PT and AB are tangent. Okay, so this picture is not a good picture, okay, because it draw too special of this AB. Okay, let me draw another picture and let's see. Okay, so we have the PR and the PT and the O. PR and the PT are tangent to the circle O, right? So if APB is 40 degrees, APB is 40. Okay, so with here is SAB, right? Okay, so it's 90 degrees and 90 degrees, right? So we want to figure out what's the angle AOB, right? Okay, so by connecting all these touching point, right, we know the A from the tangent line, so this equals this line, right? So AR equals AS, right? Then AO equals AO, right? So this is also right triangle, right? So now you know the triangle AOS is congruent to triangle the AOR, right? Okay, so let's parameterize the angle is alpha alpha. Similarly, you know the triangle, the BSO is similar to triangle BTO, okay? So this is the beta and the beta because this side equals this side, okay? Now we can see, okay, because the quadrilateral, the AR, O and the T is a cyclic quadrilateral, right? So now you know this is the 90 degree, 90 degree, right? So you know the BOT is equal to 180 minus 40 is equal to 140 degrees. If you know the BOT, right? What is the BOT? BOT is 2 alpha plus 2 beta, right? Then the angle AOB is alpha plus beta is 70 degrees. Yeah, so next problem is in the let's draw the figure. That's center at O, right? So CD is the diameter. Okay, if CD is the diameter, now let's connect the E and the A. Let's connect the AD, intersect the circle at F. Let's connect the CF. Okay, and let's connect the DE, intersect the CF at A and B. Now let's connecting the AB. Okay, this is how we do it. Because CD is the diameter, right? So that we know this angle and this angle is 90 degrees, okay? And if we know this to a 90 degrees, we know the EAD is 40, right? So now we can do some angle chasing, okay? And the ED arc is 40 degrees. That means this angle is 20 degrees. So if this is the 40, we know this angle is the 50 degrees. Okay? Then if this angle is 50 degrees, this is 70 degrees, right? Now what we want to DAB is X. So DAB is X, okay? So if you notice that the angle AEB is equal to angle AFB is equal to 90 degrees, then we can see the AEFB are concyclic, right? If they are concyclic, means the angle x equal to this angle. They both spanned by the arc of the BF, right? So the BEF is also the x. Then we also have the DECF are concyclic, right? So you can move the angles so x, x, x. Okay. If these are all the x, means if we solve the x, we solve the problem, right? Okay, so how to solve the x? Now we're starting to look at anything, all the information we can, right? To see it. So I find that we have a right triangle of the AFC. The AFC is, we have 40 degrees, so we have the 50 degrees here, right? And so now I solve the x is equal to 50 minus 20 is equal to 30 degrees. Okay, so now we know the BAF is also 30 degrees. So the cyclic quadrilateral is a very important topic for the angle chasing, because it can helps you to move your angles, okay, on the angle arc from one angle to the other angle, from one angle to the other angle. Once you parameterize all these angles, you can just see any triangle that involved with this angle that are easily solved, so you can solve the problem. Okay. Next. So question number 250. Let us draw a large diagram. So we have a circle, and we have to the ABCG, and FGDC are all parallelogram. Okay, so you can see we have the three parallel lines: AB, CF, and ED. Okay, then we connect the AD and the BC, right? Then we connected the EF. Did you see it? So you can draw these three parallel lines and connect the other one. They are also parallel based on what the problem told you, right? So G, I didn't draw it very well. Okay, it's not that very parallel, but yeah, it's good enough for we to do the angle tracing and analysis. Okay, so there's one very important thing is you need to know. I mean, within a circle, right? If I have two parallel lines, okay, then what we must have is if I connect this one, okay. So what do we know? This angle alpha equals to this angle alpha, right? That means this arc is 2 alpha, and this arc is 2 alpha, right? So on the same angle, the 2 alpha equals 2 alpha with the radius is the r, right? So now you know this arc, this chord is equal to this chord, because this chord x is equal to 2r times sine alpha, right? Based on the law of sine. And x is also called 2r times sine alpha. So if r is fixed within this circle, right, it's all related with proportional to the sine of the span angle. That's why this arc is equal to this arc. Means two parallel lines in the circle is either spanned is either isosceles, trapezoid, or a rectangle, right? So now we see this, right? Because AD, BC, EB are parallel, right? So that's why we know the AB arc is M, the CD is also arc of M. If CD is arc of M, we have another two parallel lines, is ED parallel to EF, so this is also arc of the M, right? Okay, and the other thing is AB parallel to CF, right? So the BC arc is N, so the AF is arc of the N. And also we have another parallel line, is EF parallel to AD. Then if this is the N, this is the arc of the N, right? So the question is asking you to determine what is the AB and the ED. So the question is asking you what is the M plus N. So you can see M, 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 N, N, N. So we know 3M plus 3N equals what? 360 degrees, right? So M plus N is 120 degrees. Okay, so for when you angle tracing on the circle, okay, you need to know all the inscribed angles spanned by the same arc or the same chord is the same. And also you need to be able to familiar with the tracing on the arc instead of only tracing on these angles, okay? Because normally we for the angle tracing on the circle, we're notating on the arc because there are so many angles. Let me explain why, okay? For example, this one, right? Why we're notating on the arc? Because if we're notating this arc is 2 alpha, right? No matter you pick this point or you pick this point or you pick this point, right? They all spanned by this arc. So all these angles are just alpha. you can notate in many alphas, but you're only notating one angle in the arc is 2 alpha, then you can represent everything. Question number 251. Okay, so we have a figure here is the RST as SRT, then we have the P of the A, P of the A is tangent to this, right? And the PB is tangent to the other small Simon circle. Then we have the arc has been notated as C, A, B, and D. Okay, normally when we involved with the tangent, we always put the connect with the center because there is 90 degrees. Okay, so O1 and O2. Okay, so we know this angle is C, this angle is A, this angle is B, and this angle is D. Okay, so this is the P, so we want to prove that APB, that angle APB, let's solve the angle APB, right? So APB is within the pentagon APBO201, so APB is equal to the 5 minus 2 times 180 is the pentagon, right? Then minus the 180 degrees, that's 290 degrees, right? Then minus this A and minus this B. So this one will be 3 times 180 is 2 times 180 minus A and minus B, right? So we know that A is 180 minus C because we only need the CD, right? Then B is equal to 180 minus B. So the A plus B is 360 minus C minus B, right? So you apply this one to here. Then you can say APB is equal to C plus D. Okay, so the angle tracing is a very important skill to practice because for the geometry, normally when you're tracing the angle, it's much easier to tracing the side. So that's why the trigonometry, the angle tracing, the angle plays a very important role in solving geometry problems. Okay, so that's it for the solution of this chapter, and thanks a lot. Bye bye.